Right, so this is part 2 of lesson 8. And we were discussing trying to find the equation for the line, a basis of comparison between a regular graph with a positive a value or a regular graph with a negative a value, which causes a reflection in the x axis. My drawing of the reflection is never quite as good as my drawing of the other one. Not used to drawing that one as often. So I'll just try that again. So it should be a crest and a trough of equal depth and length. Not bad, not as good as the first one. So I want to look here for how much the graph shifts this way. And the graph shifts that way 2 ticks, which is a shift to the right of 2 times pi over 6. Which is 2 pi over 6, which could actually be written as pi over 3. So that's my c value, and I know my a value was 4. So here, y equals 4 times the sine of x. Now it's shifting towards the right, so that's a minus pi over 3. For the next graph, I'm looking for the shift of the start of the graph. Where did the start of the graph go? So the start of the graph shifted from here all the way over here. I'm looking for that as my shift value. So it moved pi over 2 or negative pi over 2, but I'll count that pi over 2 plus one of those tick marks plus pi over 6. So pi over 2 plus pi over 6, I need a common denominator, times by 3, times by 3. So I've got a shift of 4 pi over 6, which is 2 pi over 3. Sorry, forgot to hit record. I calculated the shift towards the left that occurred. It was pi over 2 plus pi over 6. I needed to find the common denominator, which was 6, multiplied by 3 in the denominator of pi over 2. Did that to the top. So now you have 3 pi over 6 plus 4 pi, plus pi over 6 is 4 pi over 6, which can be simplified to 2 pi over 3. That was a shift towards the left, which means my c value is positive, and my a value was negative 4 because it flipped down. Negative 4 sine bracket x plus 2 pi over 3. So something similar is happening with cosine. Let's move down. The scale is still the same. So my pi over 2 has been divided into 3 lines. So each division is worth pi over 6. And remember what a cosine graph looks like. A cosine graph with a positive a value starts high and does that. A cosine with a negative value will start low, flip, and come out like that. So when we're looking for a greater than 0, we're looking for the graph to have shifted this position towards the right. And when a is less than 0, we're looking for the graph to have shifted this position to the left. So amplitude is 4. That's awesome. That's a nice constant on this page. Amplitude is 4. My shift, where is my shift? My shift is 1, 2, 3, 4, 5 of those divisions. So my shift is associated with 5 pi over 6 for my c value. My a value is 4. So I get to write this one as y equals 4 cosine. My shift is towards the right, so it's x minus 5 pi over 6. The bottom graph has just shifted over 1 division. So my C value is associated with what one division is worth, pi over 6. My amplitude is still 4, so that's nice, but it's minus 4 because it's flipped. Cosine, and then I've shifted towards the left, which means my C value is actually a plus. So y equals minus 4 cosine x plus pi over 6. So we've got 2 more to do. Let's turn the page. So I'm going to talk about the graph with a positive a value, and then you can try out finding the representation for the case where a is negative or a is less than 0. So I've got to take a look at how tall the graph is. The graph is from 1 to 5 tall, 1 to negative 5, which leaves an overall height for 6. I have to divide that by 2, so that I'm looking for an amplitude of 3. Well, where do I get an amplitude of 3? I get an amplitude of 3 if I move my horizontal line that cuts the graph in half down to the minus 2 mark. Now I have 3 in the amplitude position for a crest and 3 in the amplitude position for a trough. That's good. Now I have to take a look at what's happening with my shifting. So my amplitude is 3. My period. Remember, your period is how long does it take to complete one cycle, a crest and a trough. And what are my divisions worth on this graph? My scale is pi being divided into 3. So my scale is pi over 3. And I can see that the graph starts at negative pi over 3 and ends just shy of 4 pi. So it's actually a complete period of 4 pi, which means I can find my b value. Remember, period is related to 2 pi over b, which is now equal to 4 pi. So my b value must be a half. So 2 pi divided by a half will actually get me 4 pi. Minimum horizontal shift. Well, what happened to this graph? This graph shifted over one position, one tick. And we've described that scale value as pi over 3, and it shifted towards the left pi over 3. And my vertical displacement. What happened to my graph? My graph should have been centered at the line y equals 0, but it's down 2 units. So my graph is down at minus. So now write the equation. Y equals a, which is 3, times the sine of b, which is a half, times x plus pi over 3 to make it shift left, then minus 2. So I'm going to leave you to do the sine function where a is less than 0. Possibly when we're watching it in class, we can generate that on the board. This graph is similar, except it's a cosine graph. So cosine graph where a is greater than 0. My height is 6 again. So I get to cut my graph at y equals minus 2, which is my vertical displacement. My amplitude is 3. Taking a look at my period. Remember, a period is still what's the length of a crest and a trough on the x-axis. I start at that same division. I start at pi over 3 negative and go to one tick less than 4 pi. So my period is 4 pi, like it was above, which means my b value is going to be the same. Period is created by 2 pi divided by b, and that's equal to 4 pi. So b has to be a half in this case. 2 pi divided by half will generate 4 pi. And minimum horizontal shift. Where are we looking for that horizontal shift? Remember, the cosine graph is supposed to start at a height of 1, and that shifted over 2 tick marks, or 2 times pi over 3. to give me a vertical or a horizontal shift, sorry, of 2 pi over 3. And that's towards the right, so 2 pi over 3. And now I get to create my equation. Y equals 3 times cosine, don't need brackets there, 3 times the cosine of 4 pi, pardon me, b is a half, b is a half, times x minus 2 pi over 3. Remember, it shifted toward the right, so that's a minus, and then minus 2. And again, we should probably talk about the fact when a is less than 0. Remember, that would talk about a reflection in the y-axis, or in the x-axis first. So there's one conclusion on the backside. I'm pretty sure we're pretty adept at this already, but we'll turn the page. I'll pause. So domain, A, B, C, and D, do they affect the domain? Well, as far as we can tell, X is going to be an element of the reals. How is range controlled? Range is controlled by your amplitude and your D value. How is amplitude controlled? Amplitude is controlled by your A value, period is controlled by your B value, zeros. What are the zeros? The zeros are the x-intercepts. What controls x-intercept? Your x-intercept actually be controlled by everything but A. B, C, and D will control when the graph crosses the x-intercepts. Minimum and maximum values, and then we can talk about an application. So if we're looking at maximum and minimum values, we're trying to identify what our range is like. You could graph C and take a look at what your range is like. But you should be able to expect to visualize a graph. At y equals minus 4, you're going to have some graph that's doing this with a height of 3 and a depth of 3. So your y values are going to get as high as -4 plus 3 and as low as -4 minus 3. So my range is going to go from -7 up until -1. And that's it for graphing. Hope we got through all this today in class.